Alright, so we'll be recording. Alright. Oh, now I'm on something else. Come on. Nope. Let me just minimize all my thousands of tabs. Alright, let's go back to summarization. Alright. Let's see if this works. And that's dead. Alright. So, standard stuff in R. Sorry that got cut off. Basic statistical summarizations. Pretty much, if you think of a function of calculating a statistic, R has it or you can code it up. But for the most part, 99% of them are already there. Mean. You take in X, right? X is usually is a vector, right? In the cases we're talking about, that is a column of your data set. So X is, miles per gallon. Standard deviation, SD. Median, quantile. Quantile displays the sample quantiles, which are, by default, the min, the max, and the IQR. So it does the 0, 25th, 50th, 75th, and 100th percentile. If you want a different quantile, you have to pass in which quantile you want into a different argument. Range displays all the data, the range of the data, so the min and the max. Okay? It's pretty much the same thing as if you collected the minimum and the maximum, which we're introducing here. Min and max are also two functions, right? Sum takes the sum of the vector, adds everything up, right? All these things, they have to be numeric, right? If you try any things on characters, you're going to get some of the errors like we saw before, non-numeric argument to binary operator, that kind of stuff, if you do any of that. So all of these have an argument called na.rm. So we will talk about missing data a little bit later, but for the most part, they are considered NAs, right? And I don't mean not Apple. There's an actual thing in R that is capital N, capital A, right? Which is the definition of missing in R. So it's not like Stata, it's not like SAS, it's not like NAs are infinite number or it's negative infinity. It's actually something all its own. So all of these, if you think of the data from a statistician's point of view of missingness, if I am missing one person's age, I, by definition, do not know what the true mean age is, right? Because that person could be 100, they could be 50, they could be 20. I don't know. So that's why R, by default, all these, when you put in missing values, they almost always return NA, right? So it says, hey, I'm not going to jump the gun and assume you know what you're doing. You have missing data here. I want to alert you to that. So by default, if you said mean on a vector and it has missing values in there, it's going to come back NA. Because I, by definition, cannot tell you it is missing. If one person's missing, then I can't actually tell you the true mean of the data. Now, almost always, you put na.rm equals true, which will remove the NAs and calculate the mean. It will not do things like, it will not put people as zeros. It will actually just take only the data that's there and then take the mean with the correct denominator. Same thing with the standard deviation. All right, there's other transformations, log, log2, log10, square root, right? Log and log10, I think are pretty useful for me. Andrew does genomics log2 for like twofold changes, square root. Some of these transformations are important when you're doing plotting or when you're doing some data with some highly skewed values. So again, we're going to be looking at MT-cars for a bit, and we use, again, head consistently throughout this. So we recommend for you to use the viewer. Use view. Click on those things to be able to explore your data. Once you get maybe a lot more comfortable with the console, we tend to use head and tail a lot to see the top and the bottom of the data set, right? But when you're looking at those things in the viewer, you kind of get everything there. You can kind of explore that way. But if you're doing things at the command line more, or if you're printing things out in like R Markdown, which we showed you in your knitted documents and you don't want to print out everything, head is a good kind of ballpark to show you the result of some function. So again, so when we're passing these things in, we can do it in the dplyr way, we can do it the base R way. For the most part, a lot of these slides are going to do it the base R way because we're taking the means, standard deviations, that kind of stuff of one variable. So we use the $ consistently. So the mean of MT-cars, $ horsepower, right? So the mean horsepower is 146.6875. Now, the fact that that is not NA means I know that there are no missing values in that vector. I know there's no values missing horsepower. So Quantile, MT cars, $ horsepower, gives you the min, max, and the IQR and the median. That's what it gives you by default. So again, you can use median, gives you the median weight. Here, Quantile, there's another argument in Quantile, which is probably the most useful out of all the arguments in there, probs, right? So you can give it a vector or a singular number that is the quantile that you want to estimate. So I could have collected together C, 0.6, 0.7, 0.8 to get the 60%, 70%, and 80% quantiles. Okay? Ttest. We're going to cover that in way more detail later with respect to statistics and summarization, but Ttest is not a bad thing to just put in a vector and you get means and you get a 95% confidence interval off the bat. Right, so if you want to just calculate a simple confidence interval. Again, most of the t-statistics and p-values and all that stuff are really useless unless you're talking about, I mean, the fact that the weight is not 0, right, because that's the default you're using it, not very useful unless you put in, there are arguments to say, I want to compare this mean to some number. So I think, is the mean weight different than like 3, right? You can do that. And the fact is, we see the confidence interval covers 3, so we're not going to see any significant difference there. So we've talked about package called dplyr. We've talked about the tidyverse, right? There is a package called tidyr, which we will talk about. It is reshaping data, making data from wide to long. If you don't know what I mean, we'll get into that in much more detail. There is another package called broom. Broom, unfortunately, has a function. Its main function is called tidy. Right? So again, this is multiple developers working for different goals at the end of the day. So the tidy function is very, very, very useful though. What it's very useful is tidying your results a bit to get them into data frames. So for example, Ttest. This is a whole different animal altogether. It's not a data frame. It's not a vector. It's its own kind of object. But you're like, I know how to use things in data frames. I learned dplyr. These are the tools you gave me. Like, I can't do anything with this. So broom tidy, the tidy function from broom, we do this explicitly so that we just make sure you know that's where the function is. It's not in the tidyr package. The tidy function's in a different package. Don't ask me why I didn't write these, right? So we're saying the tidy function, if you do that on the Ttest object, it gives you a data frame, actually gives you a tibble where it says this is the estimate, this is the statistic, p-value parameter, confidence interval low and high, all the kind of things, and you can use subsetting, filtering, all the kind of stuff you want to with respect to dplyr. Now, not very interesting. That's only one row. So we're going to talk about later when we do modeling, right? You're going to get a linear model, generalized linear model, whatever you want, you get confidence intervals, all that kind of stuff. The tidy function will take that model object, make it into a table of coefficients, standard deviations, confidence, lower limits, upper limits, p-values, and then you want to say what terms are p-value less than 0.05 or something like that, or I want to only show the odds ratio for the treatment effect. Then, if you've made it into a data frame or a tibble, all the stuff you learn from dplyr still works. So that's why the tidy function is very important. All right. So for the most part, we're not going to be doing a lot of dplyr stuff. We're going to be working on vectors a little bit just to show you the behavior of some of these functions. So here we got x. We got 1, 5, 7. A missing value, 4, 2, 8, 10, 45, 42. Again, if you say mean of that, it says, I don't know. Can't tell you the mean. You got a missing value in there. So we say mean of x, and we put the argument na.rm equals true, remove the na, then calculate the mean, and you get something out. Note, this does not error. Quantile is a strange function in the sense like, of all the ones I showed you on that slide, nothing errors if you have missing data, just returns NA, except for Quantile. Quantile, if you have missing data, it says, I don't know what you're doing, you've messed up, I'm going to error out here. But it also has an na.rm, so if you say Quantile, na.rm equals true, it gives you the quantiles of the data set, again, the IQR and all that kind of stuff.
If you have multiple missing data points, then we can take them all out.
Take them all out. So, again, this is not a dplyr thing, but there are other functions in base R that are helpful, and usually a lot of the times what you want to do. So sometimes you want column means, right? Again, the data all has to be numeric for that to work. So you either have to use the select, you have to select from dplyr the numeric columns, or you have to do the subsetting yourself. But you can do column means on that data. Row means, probably a bit less useful, because a lot of the times you'll be working with a data set, and to do the means over a row might not make sense, right? Unless you've selected, like, let's say you have a data set where column 1 is like visit 1's blood pressure, column 2 is visit 2's blood pressure, column 3 is visit 3's blood pressure, and you want to do the row means of that, that might be a case where you use it. But for the most part, where column 1's age, column 2 is your height, right? You probably don't want to take the row means there, that doesn't make much sense. So column means, row sums, column sums are pretty useful. Column sums and row sums are really useful when we start talking about testing for whether something's missing or not, right? So there's a function we'll talk about, is.na. Is it missing? And if it is missing, it'll come up true. If it's not missing, it'll come up false. So then doing the row sums or the column sums, you can calculate the number of missing observations in that row or the number of missing observations in those columns. Summary. It's going to be really, it's a kind of generic function that's very useful for models, but it's also useful for data frames that displays kind of the quantile information from the data set. So I'll show you, I don't use that much. If you say summary cars, so some people, I think especially learning from the state of land, so summary describe or summary detail, kind of gives you some min, max, things like that. Again, I would probably more likely do this explicitly because I don't necessarily care about all these measures. I would probably just subset the ones I want and calculate the statistics I want myself. So, those people that do adopt like row means, column means, they're like, well, what do I want to do like column standard deviations? That doesn't exist in R. There is a package called matrix stats that has a whole bunch of other column and row operations, like row standard deviation, column quantiles, things like that, right? So if you have used some of these functions and you want to do the same things at a column or row level, but you want other functionality like standard deviations, variances, counts, things like that, this package might be very helpful. All right, so let's go to the first part of the lab. Which I believe should only be Do we have the lab demarcated by parts? I thought we did, but. You said you went over the labs, right? What? They're not, it's not chunked in parts, right? We're just doing questions 1 and 2 in the lab for now. Just questions 1 and 2 on the summarization lab.
This is the lab. So if you
So the third floor has like an IT department for wireless and stuff like that.
Then we just calculate mine. Okay, sounds good. Thank you.
You guys can assume the bike lanes are
you could or you could just bring it from remember?
Yes.
The URL,
Yeah.
up and down, and do we have the URL?
So you just make
Do we have to put the quotation marks?
Can you look up the labs and the keys? He's having trouble connecting to the internet. I always have one in my keychain. I agree.
What I'll show you was instead of
No, just do summarization. Yeah,
and then now we have this, and then this is the command actually.
Okay, and now
Dude, I can't believe I didn't find out a second policy. Like, it's so unintuitive. That's USB-C. There's like a dot that goes around it.
but now it's
I thought I only had one USB. No, I thought I only had one USB. Like, that's stupid. That's our portal can't have like that adapter.
For you to do that, so
You have to have. So I'm trying to plug my power. Somewhere over here.
but this one just loads it there.
That's fine.
Yeah, so if you actually wanted to use this, you need to download this, save it to the folder
and then
data, and then load it. Does that make sense?
No, just allow me to keep.
Thank you.
So as of
This is the whole game summary.
Yeah, that's what I'm saying. Just allow me to keep.
It's easier to copy the whole folder.
if you go back on it, if you, sorry, can you scroll up? No, can you go to if you want to use this, you need to download this,
For 7 megabytes.
and then you folder called data.
No, it's just
I searched.
So that's another way to load
only
it.
the first one.
And then you need to go to R. And then now,
Alright, so we're going to go through these really quickly. Again, so how many? So, okay. Remember all the bike lane data? So we read in the readr package, the dplyr, which has been kind of duplicated in tidyverse, but the JHUR package. So, again, you can either read the data in straight away if you have the internet. So, unlike Hopkins, for some reason, likes to, I don't know, their internet is interesting. So the JHUR package, again, there's a function called read_bike, which is one of the data sets we use in this data set, and I'm just going to call the object bike. So how many bike lanes are currently in Baltimore? You can assume each observation row is a different bike lane, so you can either use n row or dim, right? We could actually pipe it in as well, right? That will still work. Let me pull that up. So we could do bike. Again, because it's the only argument in there, we can pass it in there bike and row, and there are 1,631 bike lanes in Baltimore, and someone who bikes in the city, that is not true. I mean, so it probably is technically true. This data set's very interesting. We will talk about it when we do data cleaning, but some of the bike lanes have a length of 0, which isn't a very big length. And this isn't updated, so like for example, the one outside of Hopkins isn't reflected in this data set. So how many feet and miles of bike lane are currently in Baltimore? So we take the sum, we can think of everything is in feet, so we can either do, so there's around 439,000 feet of bike lanes. And then if you take the length and divide by 5,280 to get in miles, or alternatively, you can either summarize the data and divide by 5,280, or divide the data by 5,280 and then summarize and sum them up. Now, this is a good operation. I mean, this is just kind of standard kind of math operations in some respects, but sometimes this can reflect the order of which you do things can highly reflect how efficient that code is. This data set has 1,600 rows. Now the question is, what if it has 1,600 billion rows? Right? So I'm just saying, this operation sums everything up and divides one number by one number. This operation divides 16 billion rows by one number and then sums them up. So sometimes, especially if you're working with really large data, the order of the operations can affect how long it takes to run. All right, any questions about that? So again, we're just doing sums, grabbing columns with dollar signs. We will show you how to do that in kind of a dplyr way of sorts, but many times you just want to return one number, not like a summarized data frame, any of that kind of stuff. So we're going to be working with some of the TB data, so the TB incidence data that should be online, that you should be able to download using that GUI, the drop-down file, import data with this data set. You don't necessarily have to download it as long as you have this code. So here I have it on my local machine. We have readXL TB. We're assigning that to the output of readXL. So the data set is called TB, and these are the column names. So this is the type of data sometimes you download from the internet with respect to government data, right? So here, the first column is the TB incidence, all forms per 100,000 population per year, right? That's what it says, right? That first column is not that, though. That first column is the actual country of the data, right? So if I read this, I'm not going to read. So if I say head TB, right, we see that first column is actually the country that we're looking at, and each column, and every column after that is the TB incidence for certain different years. So this is what I would consider a wide format data set. So we want to change the column name, the first one to be country. Again, the JHUR package should have a read TB function for that data set. All right. So there's a lot of ways you can change that first column name. You could say column names, parentheses with a bracket, number 1 equals country, but that's not in a dplyr kind of framework. So here we say rename TB country equals this long thing. Now, we haven't given you necessarily some specifications on how should you name columns. So columns should start with letters, almost always. They should not have spaces in them. So spaces, for a lot of intents and purposes in a lot of work, is like the enemy, right? So spaces in file names, probably not a great idea. Right? If you've looked at any of the stuff Andrew wrote, almost every one of our folders did not have a space. Everything's separated by something other than a space, like underscores. Also, we know that the dollar sign extracts columns, right? You shouldn't have dollar signs in your column names, probably. When you read data in from a CSV or something like that, it might have them in there. And so, when I showed you, I showed you that data set, you see these weird backticks, right? That is because they're not ascribing to a lot of the rules R would like for a lot of column names. So, try this. TB, $1991. R has rules about numbers. So what it's saying is like, what are you trying to do? Numbers are supposed to be like things you multiply. That's not a column name. So in order to use things with, I'll say, non-standard column names, you either have to do quotes or backticks. Now, if I again show you TB, the nice thing about Tibbles is it does that. It shows you that the column names, you need to backtick them. Also, the nice thing about RStudio, if you say TB $, and then go to 1991, it fills in the backticks for you. So, the same way, I'm saying that we have to do, where did that go? The same way, I said column names are usually like with underscores and $, all that kind of stuff. If your column has any of those weird things in it, if you're using any of the dplyr framework, any of the tidyverse stuff, you have to either put quotes or backticks around it. Okay? So, start things off with a number. Or sorry, start things off with a letter. Don't start things off with a number. Don't put $signs in there. Don't put spaces in there. Don't put single quotes in there. These are the types of things that, if you do that, it will make your life a bit harder when working with dplyr, because then you have to work with these backticks. Again, not the biggest hurdle, not the biggest problem, but again, it's not the easiest thing to work with. It's another layer that makes things confusing. So, here, after we've done this, we can still say the column names. We fix one of the columns, country. All the rest of them, if you want to use $sign notation, if you want to use dplyr, any of that kind of stuff, you have to use backticks or quotes around them. I think quotes are maybe a little bit more intuitive, but I almost always use backticks because Tibbles already show me what I need to do, and RStudio fills them in for me. So, that doesn't mean you can't still use some of the selector helpers. So here, we say averages equals select TB. We're not going to pipe it in, but it's just really one line. And again, generally the rule I tend to do is if I'm piping multiple operations together, or if I'm doing multiple operations, I'm going to use a pipe. If I'm only going to do one operation on that line, I'm not probably going to go through the hurdles of using the pipe unless I really need to know the column names, which is why RStudio is really helpful. So averages, we're going to select from this data set anything that starts with a 1. This is all the data from the 1990s. So because it starts in 1990, so the column means, so we're going to show you how to use column means. So that is a data set, that is a data frame where every single column is numeric, right? If I tried column means on the original data, what's going to happen? Somebody want to wager a guess? X must be numeric. Problem. That's because the first column doesn't have numbers in it. First column has countries in it. So, again, column means can do the column means of everything, every single thing that you want, but you have to have numbers in every single column. That's why we select first, column means, and then we want to remove any of the rows where there's missing TB incidence data for that country for that year. So these are the average TB incidence over the 1990s. Okay? So it does look like there's maybe an increase here, but that's usually due to surveillance bias because other countries that might not have as good surveillance data have non-missing data later in the data set. So here, we took those averages and we want to say, I want to give for each country separately the before 2000 average. Okay? So before 2000 was that data set from 1990 to 1999. The row means we'll take every single row of that data, take the average of all the columns and average, and then give you a number back, and then we can assign that out here to the column before underscore 2000 underscore average. Okay? So now, if we look at that, we can see, for example, Albania had 26.3 per 100,000 incidents of TB from 1990 to 1999 in any of the data we have here. Andorra had 28.8, so on and so forth. Every single row now has a data set. If there are, so what happens if you have no data whatsoever? So mean, NA, NA. Gives you an NA. What happens when you say NA.rm equals true? gives you one other piece of missing information, which we will talk about when we talk about missing data. It's NaN, which stands for not a number, right? So if you've ever tried to divide 0 by 0 or infinity by infinity, it's not defined necessarily as a number. Similarly here, there's no data for us to take, right? So that is, if you ever see NaN or inf, which we'll talk about, those are infinity, not a number, which we'll handle in the missing data problem. But so if, the reason I'm saying that is because if any country just so happened to have no data before 1999, that's what it would come up as. All right, so we talked about rename, we talked about filter, we talked about select. There are versions of those functions called rename all, which we've already showed you. There's also rename if, there's rename at. Rename at will rename function. You give it a specific list of variables, and it will do a function over that specific list, rather than all of them. So all, you take in, but they all, each one of those variants have different syntax. That's why we want you to master filter, select, rename first, and then if you need to do some more complex things, because we get a lot of questions like, what if I want to rename only these 3 columns lowercase, these 4 uppercase? You can do that in a dplyr framework. They are just variants on those functions. So rename, and all those we've already discussed. Rename all, summarize all, filter all, mutate all, they exist. But some of them make more sense than others. Sometimes you rename all the columns. Sometimes maybe you want to filter all the rows based on some criteria. Maybe in this case it would actually make sense, but most cases it doesn't. There's also mutate, filter, all that kind of stuff at, where you give it a specific list of variables. And then there's mutate, filter, if. So you give it a function that tests something on that column. So many times what you want to do is, I want to take the mean of a column if it's numeric. So that's why mutate if, and what I'm going to introduce today, summarize or summarize if might be pretty useful. So, but again, we are going to pretty much cover the basic ones without the and or at, all, if. Okay? So, if something seems really, really complicated and hard with some of these basic functions, that is most likely because it's much easier to do with the variants, right? So if you rename all, so rename all, select if, rename if, select at, all this kind of stuff. So one, dplyr is great. 2, it has great vignettes, right, which are long documentations that tell you how to do it, gives you examples. 3, their help files are very bad for new users, very confusing, right? So more or less, my answer is don't look at the help files. For dplyr, look at the vignettes to learn how to do things like that. Only use the help files to find out what functions exist in dplyr. All other packages, their help files are great, but these are written for R developers. So I'm just saying, the people who wrote this are very high-level R developers, and to a new user, especially if we didn't even introduce Tibbles, you're like, what is .tibble? Oh, Tibble object. Thank you for that. That was not. Oh, okay. Funds is a single expression quoted with funds or within a quosure, a string naming function or a function. Obviously, you got that, right? No, so like even for I would say intermediate to advanced R users, if this is not a framework they've been introduced to before, this stuff is very confusing, the help file. So help is good. dplyr, it's not that great. So again, browse vignettes, dplyr, we'll bring up this page. We'll say these are the vignettes, and there was a link to it. Introduction to dplyr is the one thing you usually want to do, and this shows you again how to use a lot of these functions. It's going to be very similar to what we've done before, but I do believe they get into a little bit into the all or at. So group by at and then piping. So I'm just saying if things seem like this seems overly hard for a simple-ish operation, that is probably because that functionality is in some other variation of what you want to do. But that's not to say it's the exact same syntax. All right, so here is one example though. So we are going to use summarize. So what it does is it allows you to summarize data. So the difference now between things we've done before, more or less. So filter gives you a data set with different numbers of rows. Select gives you different numbers of columns. But essentially, it doesn't do much to the data. It doesn't change anything about the data. Summarize does. Summarize calculates something over the data. It calculates usually means, statistics, standard deviations, averages, anything you want. Anything you want to compress the data or summarize it in any way. So one of the functions is summarize all. So what we're doing here is summarize all. We're putting in this data set where we know every single column is numeric. We've already done the selecting ourselves. What function do we want to do? We want to do the mean. And we can pass additional arguments to this function afterwards. So what we're saying is take this data set, summarize everything with the mean function, remove any missing values from that data. So this is a difference between col means. Okay, this keeps it within the kind of dplyr framework. Does that make sense? Okay. So again, summary, I've already showed you. So we're going to talk about more general summarization right now. So we're going to use the Youth Tobacco Survey data, which you should already have, things like that. You should already have that in GHUR. The code's up there if you want to load it in and follow along. All right, so there's another function, which a lot of times you want to use, unique. Right? Unique will return the unique elements of a vector. It will not sort them for you. It just says, whatever order we find these in, we're going to be back. So let's say you know you have 100 patients in there, and it's patient ID 1 to 100. You say unique, and then you find out you only have 93 unique values. You're like, oh man, we're missing some follow-up data or something like that. So here, we're looking at the Youth Tobacco Survey data, and we're looking at the unique, and then we're subsetting only the first 10 to show you. Right? You wouldn't necessarily do this in a script unless you're sorting it for some reason. But this is what we're trying to show you here, that we're taking the location description from this data set, running unique on it, showing you the first 10. So it's mostly the states, but we also see in the data set that we read in that it also has national estimates. So now we've already showed you length. So why am I doing this? So length will tell you the length of a vector. Combined with unique, it tells you the number of unique elements. Right? So combining these two is a little bit more powerful than either one individually. Unique tells us the unique elements. Length tells us how many. It's 50. Well, there's 50 states in the U.S. There's 50 elements, but we already know at least one of them is a national estimate. So we already know we're missing some specific states. Okay? So some states might not have participated in the Youth Tobacco Survey. We see Hawaii's here, so maybe Alaska's missing there, but we could cross-reference that or something like that. But this is some cursory looks at your data that you already know something is not there that you might have expected. So table, very, very useful function. So it does singular tabs or two-way cross tabs. It doesn't do general like 2 by 3 by 2 tabulations, but generally you don't necessarily, I'm not going to say necessarily, you don't use them as commonly as 2 by 2, just cross tabs or singular tabs. So here, table does, it counts them up. So we pass in the vector YTS location description, run table over that, and we look at the first 5 elements of that, and it tells us, so Alabama has 378 observations, Arizona has 240, so on and so forth. Okay? So, before we do that, count. So you say, well, you're showing me a table. I gotta use dollar signs. I don't like dollar signs. So there is a dplyr equivalent. So it's called count. So you take the data set, you pipe it into count, and you tell it what you want to count up. Now, the really nice thing about count is that you can count up multiple things. You'll do all combinations of, you put location description, another variable. It will give you a data set, a data frame with those combinations in each column. So if I say the location description, let's see, do it. Age, location description, age, it does the combinations. Sorry, it does all the combinations that are observed, right? It doesn't necessarily do all the combinations, right? So If, for example, Alabama had another, there was another age in there, and Alabama didn't have it, but everything else didn't, it wouldn't have a row for zeros there. Only the things that are observed, right? So you can keep adding on things you want to calculate and count up. And here we see the output is a tibble. The difference here, the output is not a tibble. It's not a data frame. It's just a table object. But those table objects can be very useful for certain testing procedures. So count stuff up. Okay? That is the dplyr way. You don't have to use $. You can just use the column names. And if you're using pipe, you can just use tab completion and all the nice things that RStudio affords you. Okay? And then you can do select, you can do mutate, you can do renaming. So you're like, I don't like the columns named N. Okay, you change it. You know how to rename things, right? So it's now a tibble. You can do that. Okay, let's run to the second part of the lab.
Where is the second part of the lab?
Second part of the lab, good question. Actually, looking at this, we haven't necessarily introduced Summarize, so I think we've kind of segmented this a little bit differently. So we're going to keep doing with the lecture. That's a good question. Yeah, because looking at the key, sorry about that. I think that key has changed around. So, all right. So here, all right, we're going to move away from the lab. We're going to go through the lecture until I get into Summarize itself properly, right? So here we have the data set. All this code is doing is we're taking a certain subset of the data. So we're filtering it, whether the measure description is smoking status. There are other measures in this data set for the tobacco survey. Gender, we want the overall estimates. We want the response to be current smokers, and we want them to be middle school children. We're grabbing just those rows, right? And we're selecting whether we're just grabbing the year, location, description, and the data value. So these three columns. Okay? That's all we're doing. Just so we can condense the data down so it actually makes sense that we're collapsing things together. So, if you're doing data summarization, if not, probably the most important function in dplyr is GroupBy. So GroupBy will set the groups of a data set. And then any operations that you do after that will be done group-wise. Okay? So in this data set, I'm saying sub YTS equals GroupBy sub YTS year. So the data is now grouped by year. So I can put other variables. I can group it by year and then state and then other things like that. Right? Or if you're like, I want to group by treatment group and then wave and then whatever. Right? Date of birth or your age. You can do that. So here is the output. So again, this is not necessarily the way I would do it in practice. I would use piping, and I'll tell you exactly why. But the reason we did it this way is because easier syntax, only one thing, and also we want to just really hammer down that if you look at a data set that is grouped, it will tell you the groups. Okay? It'll tell you the groups in the header. So if you run something, you're like, I don't know, this ran, but it didn't seem right, and you may diagnose that because it was done because the data was grouped, or it wasn't grouped. Right? Maybe you wanted it to be grouped and it wasn't, right? But it doesn't change the data in any way. Doesn't change the rows of the data, anything inside. It just adds some attributes, but it changes how functions do operate on it. So, this is the data summarization lecture, right? Number one function, summarize. Okay? Summarize with an S or a Z, however you feel like spelling it. So, summarize takes in first argument. Every single dplyr thing takes in a data set. Summarize first argument is always the data. So again, it's really good for piping. After that, you do whatever you want. Do whatever summarization. Now, just like mutate, if you want to create a column that is the mean of the data value with removing the missing values, you can do that. But, let me see, YTS is read YTS. So I'm not going to use sub YTS for right now. I'm just going to take mean. If I didn't put, I'm not grouping anything right now. I'm just taking the mean, right? You see that column name. That column name is a nightmare, right? You don't want it to be called that. By default, it'll be called whatever function you want. You ran over it. Mean value. So again, you're creating new columns, but you're naming them whatever you want, so that it is something that you can use later in some sort of subsetting or whatever operation. And again, I could group this by year. Then it'll do that, right? But again, if I don't define this as equal to something, it's just going to give me some really long, nasty name that's not really helpful. So it's always good when you're doing summarizations to define what the output is. So this data, when I reassigned it, is grouped. There was a way to ungroup the data so that you're like, oh, now I'm doing other operations. I don't want things to work over groups. I want things to just work the way they normally do. You can use ungroup. Okay? So again, up here, you don't see any grouping variables. Now, why do I think GroupBy is really, really amenable to piping? Because most times, a lot of times, you want to group the data, summarize it, and you don't want to do any group. You don't want to keep the data grouped in any way. So you take the data, you pipe it into GroupBy. We're grouping it by year. Summarize year average equals that. This to me sometimes makes a bit more sense. We're taking this data and then we're grouping it and then we're summarizing. Okay? So does this make sense with respect to piping? Same sort of operations. It's just in one step, and then we just save the output to be YTS underscore averages. Okay? So, doesn't matter if I want to do one thing or 100 things. I want to do SD average equals SD data value. And I don't know if it's true. Let me put this over here. Again, I'm just going to use YTS. I'm going to say that's not right. So it's year SD, year median. Right? So you can do multiple summarizations by multiple, just add on different summarizations there with whatever summarization you want. So only one thing. Summarizations have to return one number. Mean returns one number. Standard deviation returns one number. Everything else returns one number. Quantiles do not. So you can't use quantiles with summarize unless you are explicitly about one probability. Like, so you can't say quantile. It's gonna give me, it's gonna yell at me. It says error in summarize impl. Well, I don't even know what that is. Summarize column year Q must be of length 1, a summary variable, not 5. So, like 0.4. There are ways kind of around this, but for the most part, easiest way to start out is just explicitly giving the probabilities, right? So YTS averages gives us mean, standard deviation, medians, and the 40% quantile. Okay? So you can see these are like addition. So whatever kind of statistic summary you want to take over that, min, max, mode is a little bit harder. By the way, I don't know if we did say this, the function mode is not like the mode of the data. It's something different in R, right? Okay. Then also after this, you can pipe that down in anything else. So we piped in the group by year, calculate the year average, and we can arrange it. So now we could have done that with summarize. We did it with mutate. Okay. Summarize summarizes the data down. Mutate just adds columns, right? It doesn't do any summarization. So here's the big difference. So we took sub-YTS before, grouped it by year, and then summarized by the year average. Here, we're mutating the year average, right? So what is that doing? That's saying group the data by year, calculate the year average, and then repeat that number over and over again for each observation in that year, right? So let's say in 2000, so in 2000, Alabama, first and ninth row, both have the value of 12.5. Okay? 2000, Arizona, Alabama. The year averages were still the same. Over all the states, or over all the locations that we have here, we calculated an average, right? Average smoking status or whatever. And the idea is we took that and we calculated we took all those things, took an average, and then we added a new column. And that data point is repeated, that average is repeated for each year. Does that make sense, right? So let's say for a person, let's say you have longitudinal data and you have patient follow-ups and you have patient at visit 1, 2, 3, 4. And you wanted to calculate the patient maximum blood pressure or something like that. But you didn't want to condense the data down. You wanted to add a column that's, for patient 1, their max blood pressure was like 180 or whatever, right? So that number, 180 or whatever, is going to be repeated 4 times. Visit 1, visit 2, visit 3, visit 4, right? Does anyone not follow? Right? So mutate adds a new column, but by the grouping variable, it's repeated, right? So sometimes you want to do this, right? For example, you want to get days from baseline. Person visit 1, 2, 3, 4. You want to say, what's the minimum visit date, right? And then you want to repeat that. And then you want to say date minus visit date, date minus min visit date, date minus min visit date. So now you have the days from baseline, or you have the introduction into a study, any of those kind of things. So this is why mutate is important, whereas summarize is not what you want to do. But the data is grouped, so different operations are going to work differently. Okay? Tally is a shorthand wrapper. Is a short wrapper for just counting, essentially. So, so summarize. There's a function called n. So n with parentheses around it counts the number of observations, right? After you group it. So we group the data by year, saying how many observations did you have by year, or how many rows, essentially. So 1990 we had 10, 2000 we had 27, so on and so forth. And head, don't worry about that. Again, we're just showing the first 6 rows, so we don't print everything out. Here, we're doing the same thing. Instead of saying summarize n equals n, parentheses, we say tally. Yeah?
Does tally automatically make it the header n?
It does. I believe, I'm pretty sure you can, you definitely, I think tally on its own will do that. We'll always call it n. I believe you can, I believe with count you might be able to define it as something else, right? Otherwise you would just use rename after that. But that is a problem if there is a column n. No, it's actually not a problem if you have a column n, because it doesn't summarize anything else. Just summarizes the counts. This you can do multiple things. Summarize can do means, ends, all that kind of stuff. Tally will only give you that out, and it always will call it n. And it won't, like if you had a column in that data set already called n, it's not going to be a problem because tally isn't going to do anything with that column. Right? Now, I think, since we have about 5 minutes left, we can work on part of the lab, which I think is useful. But at the end of certain days, I think it's still kind of useful to just get open questions. Because I know you don't necessarily know what we're going to cover completely yet. So just want to get kind of a feel if you're like, are we going to cover this? We can definitely tell you right now the answer is yes or no. Or any outstanding questions. Because again, this is a lot to take in. Usually Wednesday, if you're drinking out of a fire hose today, tomorrow sometimes a little bit of drowning. So it's not drowning. It's so much in so short amount of time. So we always want to break down and say, what is confusing right now? Because the answer I know is not. We're not. We try to teach, but we're not that good at teachers that nothing is some people. So about pipes. What about how do I know where these functions are, or how to Google for things like this, or
Is it the memorization of just knowing a lot of those functions? Is that just practice?
Generally, yeah. Dplyr verbs, when you're using them consistently, you'll get the hang of those, right? By the end of the week, you'll know that, like, oh yeah, I want to sort the columns like it's a range. I want to take out some rows. Sometimes you'll flip between select and filter, but it's very clear when things aren't right, because you try to do like miles per gallon is greater than 5 on select, and it's like, I don't know what you're talking about. So those pretty much over time just become pretty intuitive and second nature. Piping takes a little bit of time, but if you start out with that in some respects, it makes it maybe a little bit easier. I'm not sure. Because again, like we've tried. I don't know if we've. It's a hard subset of people to find, but I want to find people that like kind of only learned R in the last like 3 to 4 years, because they have learned a totally different framework than when Andrew and I do remember the first time I learned. I asked a bunch of questions to a postdoc in our department, and he. So I use X for a lot of temporal variables, X, Y. I know people that have different notations. Somebody uses junk 1, junk 2, junk 3. He used a lot of, he used animals, like farm animals. So like cow was this, pig was that, and there's like sheep was this. And so I just thought that was very interesting. So I will say, just like your style of writing, your style of coding is pretty unique to you for the most part. So I can usually identify. I could probably identify, if I've seen enough of someone's code, identify who it is. But yeah. All right. Well, we will go over the lab maybe tomorrow. But pretty much the lab starts at 3, and we will probably go 3 to 6 for lab part 3. Yeah. And then we'll pick up at this spot tomorrow.
Homework to do.
Yeah, it can be Thursday. So we're very open in the time. We do give deadlines more or less because people in the course have asked for them. It's okay to give us them all at the end once you've gone through them. But other people have asked for them because like they only have this amount of time to like take the course, and like when they go back to work, they're like, I'm not going to do any of this homework, so I need to grade. So we're like, all right, give it to us Thursday. Usually give it to us Friday anyway. But yeah, so don't necessarily worry about that. Just email all 3 of us if you can. Just CC or CC everyone, just so we all have it, so it doesn't get lost through the cracks. And we'll try to do an update Thursday or Friday, saying like, this is what we have. Homework's from you. Did something. If we missed anything, let us know. And then again, the final project is not much different than kind of a somewhat basic data analysis or visualization. Does everyone have a data set that they might have in mind?
Yeah.
You don't have, okay. I mean, you can use, we can give you something, you can find something online. It's not necessarily crucial exactly what it is. We just find that like giving a project with a data set, people are like, well, I already have like 10 data sets on that. So just email us if you want us to give you anything, unless you want to find something online.
When do people start working on those projects usually?
Those are typically due in like 2 weeks.
Yeah,
Yeah.
Time.
Okay.
Yeah. And I mean, if you're really time constrained, I think the grades are due like the end of
3 weeks or something.
Yeah, 3 or 4 weeks. So if you really want to work on that, want to get feedback from it, but can't turn it around within a certain amount of time, we can definitely extend it. So the R Markdown and the HTML and the output. So
Yeah.
of what you did, and so Also, if you need, if so, we were going to try to knit the document. So if you have data, you need to put it in there. But if you can't give us the data, you can give us like a jump drive and we'll delete it after.
I mean, the HTML is probably okay. In the past, I think we've just taken HTML.
Yeah, I mean, yeah, that
we
should be
see the output of the
Yeah, that's true.
So just make sure all the code gets like printed. Don't have it like hidden. In the document.
Yeah.
Good.
But also try to clean up, not just like every single command you ever tried in there, right? Where it's like, oh, I like
the first 500 rows of my data set.
Yeah. So actually, look at the HTML maybe before sending it. Yeah. Do you have something? You good? All right.
See you guys tomorrow.
I'll see you tomorrow. Batteries are dead in this guy.
Yeah, no, that's why I gave up.
Yeah, but.
Like, what the?
Yeah, I know. Dad, it's tested. I even did this before you got here. I tested it. I was like,